or two until we see the top of the hour, and then we'll start. Okay, we're at the top of the hour, and again, welcome to Concrete 101, the basics of concrete, presented by the Illinois Ready Mix Concrete Association. Just a little bit about our association. We represent over 92% of all the ready mix concrete producers throughout the state of Illinois. So within our group, we have a technical committee, we have operations, environmental safety committees. We work with IDOT, we work closely with the tollway. We work with our municipalities and counties. And one of our primary goals is to promote concrete. But there is this other side, and that is the planning and engineering. And we're talking to the decision makers, those of you that are engineers that prepare those decisions for the owners to make sure that they purchase concrete for their pavements, parking lots, and then all other aspects of concrete. So welcome. Thank you for being here. My name is Jim Randolph. I'm the executive director for the Illinois Ready Mix Concrete Association. Next. Next slide is talking about our antitrust statement that we're not going to read through that, but we just adhere to the rules so that we don't talk about any pricing, jobs specifics, or anything in that nature, anything competitive in nature. You also want to be let know that we are recording this webinar, and we want to also invite you to visit our website at irmca.org. There you will find all of our webinars on the website that have been stored there, so you can go back and look at these at another time. We want to say thank you to our sponsors on the next slide, listed here. And each one of these sponsors, many of them have additional information regarding these webinars. If you go to our website, you'll find their logo. You'll find more information there. They have up to three links there. Now, if you have questions today, we want you to go to the bottom of your toolbar at the Q&A and type in your questions, and we'll try to get as many of those answered as possible. Also, at any time, you can call IRMCA, call Theron Tobalski, or email him, and if you have any questions or need any assistance. So with that, on the next slide, I'd like to introduce to you our Assistant Executive Director of the Illinois Ready Mix Concrete Association, Theron Tobalski. Thank you, Theron.
Thanks, Jim. I thought we'd start out today with a nice, easygoing meme. Me every time someone calls concrete cement. That's why we're here today, to increase everybody's knowledge on concrete. Up in the top, we have actual concrete, and to the right of that, we have a concrete truck. And at the bottom, we have cement and a cement truck. So two completely different things, but two words or phrases that often get miscommunicated. So first things first, when we talk about concrete, right? If you're in the concrete industry, you kind of have to know the rules. How do you design concrete? How do you place concrete? What are the rules that the industry follows? So we have ACI, the American Concrete Institute, ASTM, AASHTO, FHWA, and FAA. These agencies make the rules, standards, guidelines, and certifications for the industry so that concrete can be designed, produced, tested, and placed properly. Right? As a concrete producer or engineer, you want to read them, learn them, preach them, and practice them. Those are kind of the rules and guidelines on how we do concrete. Where do we supply it to? We have IDOT, municipal work, county work, Chicago Department of Transportation, the Tollway Authority, and airports. They take those industry standards, they modify them, and then they enforce their modified rules. So they kind of take what you typically do, they edit it based on their knowledge or their focuses, and then they ask the industry to follow their modified rules. But then when you look at residential work, commercial work, industrial work, healthcare and schools, high-rise buildings, they basically follow those rules to a T. The specifiers specify ASTM, AASHTO, or ACI, and that's kind of what you do to follow those projects. So what is concrete, right? Concrete is essentially a mixture of two ingredients, aggregate and paste. The paste is made up of all the cementitious materials such as Portland cement, fly ash, slag, Portland limestone cement, silica fume, and other materials, right? The paste binds the aggregate, forming what you end up with as concrete. The various components, as you'll learn today, can be adjusted in their weights and amounts in the mixes to make the concrete mixes act all different types of ways. A typical cubic yard of concrete that we see here is 300 pounds of water, 564 pounds of cement, 1,200 pounds of sand, and 1,800 pounds of stone. That is what is in a typical cubic yard of concrete. But when you see on the right here, we actually, concrete is a lot more complex. You can do type 1, type 2 cement. You could do Portland limestone cement. You could add SCMs to your concrete mix, which is fly ash and slag, which is most commonly used in the Illinois market, right? There's air in there for freeze-thaw durability. There's all kinds of admixtures that you can add to your concrete mix that we'll cover in a little bit, right? We're gonna have some amount of water in our concrete mix. And then a standard mix is gonna have a fine aggregate like a sand, and then a coarse aggregate, 3/4 or 1 inch top size. But some mixes actually also have chips in them. You could have 3 aggregates. So depending on the concrete producer's complexity and how they like to make their mixes will vary how all these different components are used in their concrete. So we're going to start with one of the basic ingredients, Portland limestone cement. So the governing rules for Portland limestone cement would be ASTM C150 or AASHTO M85. And what we mostly see in our market is type 1 normal use cement or type 2 moderate sulfate resistance. So most producers in their plants will carry those two types of cement, Portland type 1 or Portland type 2, or some are Portland type 1 type 2. So that's the most common type of cement that we see in our industry for concrete. But there are also various other types of cement. ASTM C595 blended hydraulic cements allow for slag, fly ash, Portland limestone cement, or ternary blended cements, right? So we take two different type of products, blend them together into a cementitious material that'll have a hydraulic reaction, and those are all covered into ASTM C595. I'd like to talk a little bit about Portland limestone cement. This is kind of the new topic in the state of Illinois and the concrete industry in general. Concrete producers are looking to move to using Portland limestone cement that we just covered in the last slide. It has the same durability as the type 1, type 2 that we're currently using. It has the same resilience. It has a 10% carbon footprint reduction, right? That's the other kind of hot topic in the industry, carbon reduction of concrete. So if you allow a Portland limestone cement to be used on your project, you automatically get a 10% reduction in your carbon footprint. PLC gives specifiers, architects, engineers, producers, and designers a greener way to execute any structure, paving, or geotech project with virtually no modifications to a mix design or placing procedures. Again, it's very similar to the type 1, type 2 that you use and specify on a daily basis. The Illinois Department of Transportation and the tollway both currently allow for Portland limestone cement in their specifications. If you go to www.greenercement.org, there's a whole host of information on Portland limestone cement. How does Portland limestone cement differ from type 1, type 2? PLC is made by integrating regular clinker with up to 15% limestone, while the regular type 1, type 2 has 5% limestone. So the only major difference in Portland limestone cement versus the typical ASTM C150 type 1, type 2 cement is 10% of limestone added during the cement process. And this is just a quick diagram that shows that 95% ground clinker with 5% limestone versus 85% ground clinker with 15% limestone. As we covered earlier, this is kind of where the concrete industry is looking to go to move towards Portland limestone cement, or at least to allow it on our projects. Why are concrete producers still using type 1, type 2 cement instead of using Portland limestone cement? There's three basic reasons why we haven't seen, at least Illinois, get that movement over to just doing Portland limestone cement. There's specifications, silo space, and availability. So let's start with specifications. When we bid concrete projects, if the specifications do not allow for Portland limestone cement, we then cannot supply it on the concrete in our concrete for those projects. For a concrete producer, right, our cement is stored in a silo, which you see here on the slide. Concrete producers only have so many silos at their plant. So 95% of the concrete plants in Illinois cannot carry a Portland limestone type 1, type 2, and Portland limestone cement at their plants. They kind of got to pick one or the other. So they're looking for the engineers who design work in Illinois to allow for Portland limestone cement as an option so that they can start emptying those silos out with type 1, type 2 and moving to Portland limestone cement. And then it's kind of the chicken and the egg, which came first scenario, right? For cement companies, some of them can produce both type 1, type 2 and Portland limestone cement. Some of them have to produce one or the other. So we kind of go back to that. The concrete and cement industry need the specifications to be updated and changed to allow this movement to Portland limestone cement. Next topic we're going to cover is water cement ratio. This is one of the most important aspects in designing concrete and having durable concrete out in our out in the world, right? So the water cement ratio is the weight of the water in the concrete mix divided by the cementitious materials in the concrete mix. And when we say cementitious materials, we mean the Portland limestone cement, the fly ash, the slag, or the type 1, type 2 cement. And an example of that would be a mix that has 275 pounds of water divided by 564 pounds of cement would equal a 0.49 water cement ratio. In a basic concrete mix, you need a minimum of 0.23 water cement ratio to get full hydration. And we'll cover what hydration is in a minute or two. Any excess water that you have in a concrete mix above the water cement ratio that mix was designed for will result in a weaker or more porous concrete. So from a durability standpoint, every concrete mix is designed with a water cement ratio that allows that concrete mix to meet the specification it was designed for and to be durable. And every gallon of water that you add to a concrete mix that takes that mix above the designed water cement ratio really dilutes the quality of concrete that you're using on your project. It doesn't guarantee that the concrete will be bad or will fall apart, but it really, really increases the chances that it will every time you keep going up above that water cement ratio. We'll show you a little bit what hydration is, right? So we have our cement grains, these circles, and they're surrounded by water. As the cement grains chemically react with the water, fuzzy finger-like crystals reach out to each other. As you can see, that's starting to happen. These fingers start to interlock with other fingers of other cement grains, and they grab onto the sand and gravel particles that are in the concrete mix as well. Eventually, these crystals get so intertwined that the concrete stiffens, which we call set. And as the water and cement are used up, the crystals form a hard, dense structure, which we know as concrete. All the water that is not used during the hydration process ends up evaporating and leaving little channels inside the concrete mix. And this is just a picture microscopically that shows that exact process happening. You can see all the different crystals, finger-like structures interacting with each other and intertwining and forming that hard, dense structure, right? So we get water contact to cement grains. That chemical reaction called hydration takes place. Hydration is exothermic, which means that process gives off heat. And then small needle-like crystals begin to form and interlock. And that's what we want to happen. We want just enough water in that concrete to hydrate all those different cement particles, and nothing more, nothing less, right? That's the goal in basic concrete. Effects of water on compressive strength. So, right, we've talked a little bit how the right amount of water is perfect for concrete, but if you add a little too much, that's bad for concrete. How bad is it? So if we look here at this graph, we're going to look at the air-entrained concrete in green. If we look at the 0.4 below, the water cement ratio, and we go up to the green mark, we see that that concrete is about 4,700 PSI, right? That's a good concrete strength for exterior concrete. As we add a little water to that mix and we go above the 0.40, we end up at 0.45. You can see the dramatic drop in strength for that concrete mix, right? We went from 4,800 to about 3,500 PSI. And as we watch all the way to the end of the graph, as we get to a 0.7 water cement ratio, we're back down to under 2,000 PSI concrete. That concrete is not going to be freeze-thaw durable. That concrete's going to fall apart and it's going to have all kinds of issues. So this is just a good visual to show you how you really need to maintain the water cement ratio that that mix was designed for. These are some rules of thumb, right? Adding 1 gallon of water to 1 yard of concrete, it'll increase the slump by 1 inch. It'll cut the compressive strength by 200 PSI. Waste the effect of 1/4 sack of cement. It'll increase the shrinkage potential by 10%. Think about that for a minute. 1 gallon of water increases the shrinkage potential by 10%. Think about how many gallons of water can be added to a truck on site. There could be 30, 40, 50 gallons of water on some projects. So it really has a major effect. It decreases the freeze-thaw resistance by 20%. It decreases the resistance of de-icing salts. It increases cracking by 10%, right? Nobody wants a cracked concrete pavement. That happens, but we don't want them. So again, 1 gallon of water increases cracking by 10%. It increases the air content by 1%, right? Every yard of concrete that we'll be seeing freezing and thawing has a air percentage range that it needs to be in, typically 5 to 8% to be freeze-thaw durable. So every time you add water to a yard of concrete, you increase the air. And when you increase the air, you actually decrease the strength, which then hurts the durability. So you kind of got a 2-for-1 whammy against your concrete when you're adding water. It increases segregation, which means it causes the mix to potentially fall apart where, you know, aggregates go one way, cement goes and water goes another way. It increases dusting. So when the concrete hardens, it could be very dusty on the surface. It increases finishing time for your labor, right? You have a lot of guys out there waiting to finish the concrete. If you add too much water, it takes longer to set and dry out to where they can start their finishing practices. So it ends up costing you money. So we're talking a little bit about supplementary cementitious materials, right? We talked about a concrete mix. A basic one just has cement and water and aggregates. But now you can actually add some things to your concrete to make it work and perform better. We typically can add fly ash, slag, natural pozzolans, or silica fume. In the heavy commercial, light industrial, driveways, sidewalks, in the state of Illinois, the most common are fly ash and slag. So that's what we're going to cover today. Right, as part of the industry rules of thumb on how you do concrete, ACI 301, the specification for structural concrete, kind of gives you a chart on how much fly ash or slag you should put in your mix. So for fly ash, you're allowed to go up to 25%. For slag, you're allowed to go up to 50. For silica fumes, 10. For a combination, 50. And that's mostly what we're concerned about today. So if you're looking for a guideline on, hey, I'm a specifier, how much fly ash or slag should I allow in my concrete mixes, this is a great rule of thumb to kind of help you decide what you should or shouldn't allow. So we're going to talk about fly ash for a minute, right? Fly ash is one of the most common supplementary cementitious materials that we have. It's a byproduct from burning coal and power generating plants. The two main types that we see in Illinois is a Class C and a Class F. Most producers, if they're carrying fly ash in their plants, are a Class C fly ash. The advantages is it increases your workability because it's a round particle. It rolls really well, and it really helps with finishing and the workability of concrete. It reduces the permeability. Permeability, we're going to cover that in a couple minutes about what permeability is. So I'll wait a minute. We'll cover that in a few minutes. It improved sulfate resistance, and it improves ASR mitigation. As I mentioned earlier, there's two typical types of fly ashes being used, but as fly ash availability shrinkens, and there's not always fly ash sources around, some people have moved to blending a C and F ash to get another type of ash, which is allowed. We see it used quite successfully. So that's just another issue for a type of fly ash that you can use. But as mentioned earlier, C and F ash are the most common that we see in the state of Illinois. Typical amounts of fly ash and slag. Fly ash, we typically see a Class C ash of 15 to 40% replacement. A Class F, we see 15 to 20%. And slag, we see a 30 to 80% replacement. And again, caution should be used. If you're going to be using over 35% replacement for any concrete that is going to be in a freeze-thaw scenario, like an outside parking lot or driveway, you really need to be careful on using those high replacements. They tend to take a little longer to set. You could cause the contractor to have some finishing issues. So again, it's not that you can't use them, but if you're going to use them, you got to make sure that the concrete producer and the concrete contractor and the engineer are all on the same page, and make sure that we all understand how those concrete mixes with high replacement is going to act. Talk a little bit about slag. What is slag? It's another supplementary cementitious material. It's a byproduct from the iron and steel making from a blast furnace slag. There's three types: a grade 80, a grade 100, and a grade 120. The advantages, kind of very similar to fly ash. It increases workability, it reduces permeability, it improves sulfate resistance, and it improved ASR mitigation. Typical amounts of concrete mixes, right? We have seen up to 95%. Most people in our market in an outside flat work are probably 30% or less. 40 to 50% is most commonly used. Slag or fly ash used in the mix also is going to change how the concrete acts. And I feel like this is a good chart to show you. So we see here under 7 days, the gray is a straight cement mix, and the blue is a 25% replacement with slag mix, and the greenish color is a 50% replacement of slag. So you can kind of see in the 7-day range, the straight cement mix outperforms from a strength standpoint compared to the slag replacement. But when you get out to the 28 days and even longer, the slag 25% and 50% replacement actually outperforms the straight cement mixes. So again, using slag and fly ash in concrete is actually really great and wonderful. And you just have to know how it's going to act. So those early strengths are going to be down, but the later strengths are going to be up. When we talk about concrete mixes, there's a couple different ways that a concrete producer or the engineering industry can allow concrete mixes. The first column you see is straight cement. So we have 564 pounds of straight cement. There's no fly ash and slag. And then we have water, stone, sand, and air. This is for a 4,000 PSI entrained air mix. And then what we call a binary mix. A binary means we have two cementitious materials. So this one actually has 420 cement and 100 slag. We drop down to 31 gallons of water. We actually add a water reducer at the bottom here, and we get above 4,000 PSI. You can also create a binary mix with 420 pounds of cement and 100 pounds of fly ash. Again, we add our water reducer and we're a 4,000 PSI mix. You can also do what they call a ternary mix. A ternary mix just means that there's 3 cementitious materials in your concrete mix. There's 390 pounds of cement, 45 pounds of fly ash, and 90 pounds of slag, 31 gallons of water, and we also add that 3.5 ounces of a water reducer. These mix are all going to perform well. They're all going to be freeze thaw durable, and they're all going to achieve the 4,000 PSI specification that you wanted. We're going to cover permeability for a minute. What is permeability? We talked about that fly ash and slag help with permeability. It's the measure of how easy it is for water or other substances such as chloride ions or sulfates to enter the concrete, right? We really don't want those products getting into the concrete, right? Because they corrode the steel or they could cause extra freezing and thawing issues. So to reduce permeability is a good thing for concrete. We commonly measure that by ASTM C1202, the rapid chloride permeability test, right? Low permeability concrete can reduce corrosion potential for embedded reinforcing steel. How does slag cement affect permeability? Low permeability can be achieved in binary or ternary mixes with up to 25% to 65% slag cement substitution. So again, there are really great benefits to allowing slag and fly ash in your concrete mixes. So the overall benefits of using fly ash and slag, you get higher overall strengths, you reduce environmental impacts of concrete, right? Because we're using recycled materials. We have lower earlier strength, right? Lower earlier strength is going to cause your construction schedules maybe to push back a little bit. So you got to be aware of that. We get lower set times. It's great for summer, but not recommended in the winter, right? When it's real hot outside, we really want some slow setting concrete compared to fast setting concrete. So fly ash and slag are good for that. It also slows down the heat of hydration, right? We talked about when the cement hits water, we have that hydration process that starts so that the concrete can set and become a hard concrete material. Well, we also give off heat. So the more cement you have in there, the more heat you're going to generate. So if you're pouring some mass foundations or something where they're 5-6 feet wide or thick, it's a great way to mitigate that heat is by using slag or fly ash, right? It really brings down that temperature in the concrete. It also reduces water demand, right? Right, we kind of talked about that there's a certain water cement ratio, and the more water you add that goes above that water cement ratio, the more harm you do to the concrete. So by using fly ash or slag, it reduces the amount of water you need to get this desired workability of that concrete mix. And we also talked about that they lower the permeability, right? So less salts and chemicals can enter the concrete to do harm. Right, the one thing we have to caution you about, we kind of talked about this a little bit, is when you use high replacements with fly ash or slag, it slows down the bleeding process, right? We need to be careful. When finishers are finishing concrete, they wait for the bleed water to come up, and then it dissipates and goes away, and then they do their finishing on the concrete. If they finish the concrete too early and they trap that bleed water in the concrete before it can dissipate, we see things like scaling, delamination, or mortar flaking, right? Those are all bad issues with concrete. So again, it's really good to use fly ash and slag in your concrete. You just have to make sure that your concrete contractors are educated and they know that, hey, these are high slag or fly ash mixes, and we need to make sure that it takes a little bit longer to get that bleed water out of there before we start finishing. We also need to cure concrete for 7 days. Curing is probably one of the most underutilized technologies that we have to help concrete be successful, meet the goals it was designed for, and to be durable. So again, if you're going to be using fly ash or slag, you really want to make sure that that concrete is being cured for 7 days. And we're gonna have a couple slides on curing, so we'll cover that in a little bit. The next part of the presentation we're going to talk about is concrete aggregates, right? We covered cementitious materials and water in a concrete mix. We're going to talk about aggregates a little bit, right? So in a typical concrete mix, you can use sand, limestone, or gravel as your top size aggregate, or you can use chips or pea gravel, for example, as a smaller aggregate in your mix, or you can combine chips in your pea gravel and in other aggregates to use multiple aggregates in your mixes. How do we know that we've got the right type of aggregate and that it meets the specifications governing that sand or stone? The answer is we use what we call a bunch of sieves to do a sieve analysis of that material, right? So in a concrete yard, truckloads dump a bunch of sand or dump a bunch of 3/4 inch stone, and we take a sample of that pile to see, is it good? Is it of the right quality for our concrete? And you can, as you see here, a 3/4 inch stone has all these different sieve sizes that are required, going from very large holes on top to very small holes on the bottom. So we stack all these sieves up, we dump the aggregate in the top, and then we shake it in a machine that causes the different size aggregates to fall throughout all the different sieve sizes. And then we actually weigh them and we see how much material is retained on each size sieve. So if you look at the sheet here, this is basically a gradation sheet. It shows the amount of material that was weighed, the amount that was retained, and in this last column, this is what we're concerned with. We actually see the percent passing. So we see the IDOT specification that shows the different allowed percentages of material on each sieve to be considered a good material to use in concrete. So you can see that on the 1 inch sieve, 100% passed, and that's what they were looking for IDOT. On the 3/4 inch sieve, 92%, 0.5% passed, and they were looking for 84 to 100%. And as you go down, you can see all the different percentages that are required and what actually happened. So this is how a concrete producer on a daily basis would sample all the aggregates they have and then do a sieve analysis on them. But sometimes when we grab samples, we can get well-graded material, poor-graded material, or gap-graded material. So a well-graded material has all the different sizes that were required in the sieves. A poor-graded is a stockpile that has only large aggregates. And a gap-graded material means that it only has large aggregates and very small aggregates. There's no intermediate or medium-sized aggregates. And believe it or not, this kind of happens from maybe an accident happened in the production of an aggregate and a sample was taken and brought to a concrete plant, or maybe the way the concrete producer is stockpiling his aggregates, he caused one of these scenarios to happen. But this is exactly why we sample our aggregates on a daily basis, test them, and make sure they're of the right quality. Because if you have a gap graded or a poorly graded material, you can affect the way the air goes into the concrete, the strength, the durability, the rate at which the concrete bleeds, or the workability or finishability of that concrete. Gap graded aggregates, as you can see here from this slice of concrete, this has the very large sizes and small sizes. That this type of concrete would segregate more easily. It'd be difficult to place. It would have a high amount of fines. It would require more cement, and it'd have a greater water demand. So that's what happens when you have a gap graded aggregate that you use in your concrete. But when you have a well graded aggregate, you can actually see this slice of concrete where all the different sizes are well represented. It's less prone to segregation. It's easier to place. There's lower amounts of fines. It requires less cement and less water demand. Now that we covered aggregates, cementitious materials, and water, we're going to talk about admixtures. Admixtures are wonderful. An admixture can solve every type of problem that a concrete contractor can have for placing, consolidating, all the issues that contractors have on projects. There is a chemical admixture that can fix it. So we have air entrainers, water reducers, super plasticizers, hydration stabilizers, waterproofing, corrosion inhibitors, shrinkage reducing admixtures, and color pigments. Most concrete producers have most of these different admixtures at their plants on a daily basis. Right, so we talked about in the beginning, you got to know the standards that are out there to create concrete. So ASTM C494/C260 is the industry rule governing the different types of chemical admixtures. There's type A all the way to type S. These different admixtures listed on this page are the most common types of categories that concrete producers use to make concrete on a daily basis. We're going to look at these admixtures a little more in depth. So the primary purpose of air entrainment is to create and stabilize and entrain millions of tiny bubbles to improve concrete's freeze-thaw durability. So in any concrete that is going to be outside, that is going to be susceptible to freezing and thawing, you have to put an air entraining chemical in there that creates all these little bubbles to make that concrete freeze-thaw durable. It also improves workability, but air, every percentage you go up, it reduces the strength, it minimizes segregation, and it can be expensive. So again, it's a necessary product that you have to have in your concrete if your concrete is going to be exposed to freezing and thawing. What affects air, right? So cement content increases the content, excuse me a second, increases in content lowers air, right? So if you have 400 pounds of cement and you add some cement to your mix to improve the strengths or durability, you might have to adjust the air content in your concrete. Increase in alkalis raises air. So if you have a low alkali cement and you switch to a high alkali cement, that'll affect the amount of air in that mix design. Fly ash has carbon content in it, right? So as carbon contents fluctuate, the carbon absorbs air. So a high carbon fly ash would actually make you need to increase your air chemical in the concrete to get the same 5 or 6% that you want in your concrete mix. When you use slag, increase in fineness in the slag may lower the air. If you use a mid-range, as dosages go up, less air is needed. So mid-ranges kind of help you entrain air in the mix. Some of the new high-range water reducers, low doses would have less air in there. Increase sand. If you increase the sand in your concrete mix to maybe help it finish more, you might have to change your air content. Air increases with the water cement ratio, right? So every time you add a gallon of water and you increase the slump, you also increase the air. Hot and cold temperatures. If your concrete gets too hot or too cold, that can also affect the air content in your concrete mix. What about on the job site? Slump loss, right? So if you want a 5-inch slump on your concrete and your air gets there at 5-inch slump and 7% air, if your concrete dries up to a 2-inch slump, you're going to lose a bunch of air. When you retemper, so when you add water at the site and you mix it up, you're going to affect the amount of air in that mix. The length of time that on the truck, right? The longer the concrete sits on a truck, the more it's going to want to dry out and the more it's going to affect the air content. If you add admixtures on a job site, maybe you add super plasticizer at a job site, that might affect the air content in that concrete mix. When you add color, that can affect the air content. Fibers, some fibers can react with the air and maybe make the air fluctuate up or down. So improper testing, right? If your air meter isn't working right, that's going to affect the reading that you're getting. And pumping causes havoc on air contents, right? Depending on whether the boom's straight up and down or extended out, that whole process causes air to go up or down. So it does have a major effect on the air content in the concrete. Water reducing admixtures, right? There's 3 different types of water reducing admixtures that concrete producers typically carry. There's a low range, mid range, and a high range. And you can see a low range has 5 to 10% water reduction in the concrete, a mid range has 6 to 12, and a high range has 12 to 40. And if you can see here in this picture, first you have a 0.4 water cement ratio concrete with no water cement ratio. There's 695 pounds of cement. You can see that when they did a slump test on it, the concrete didn't even fall. There's really no slump there. It's a 0 or ½ inch slump. But when we took that same mix and all we did is add a water reducer to it, we got a 3-inch slump. That concrete became a little more workable and easy to use. And if we took that same mix and we add a super plasticizer, we actually got a 7.5-inch slump. So you can see that concrete fell pretty low. It's a real flowing, workable concrete mix. So it just kind of shows you the power of using admixtures in concrete and how they can change the workability or quality of the concrete that you're using. Another way to explain water reducing admixtures, if we took a mix with 500 pounds of cement and 300 pounds of water, we would end up with like a 5-inch slump. If we took that same mix and we added a water reducer to it, we would end up with a 7-inch slump, and we'd still be at that same 3,500 PSI concrete mix. So all we did is add a water reducer and we gained 2 inches in slump. We also could add that water reducer to that same mix, drop the water a little bit, so we would stay at that same 5-inch slump, but we'd actually be bringing the water cement ratio from a 0.6 to a 0.56, and we would actually create a 4,000 PSI mix. So we would be 500 PSI better than our previous two mixes. So it just kind of shows you the different ways water reducers can be used. We're going to talk about retarders versus hydration stabilizers, right? When concrete wants to set and take off and set and harden on you, you can actually put what they call retarder in the concrete, or hydration stabilizer. And here we see on the first bar, hot weather, we have the initial set, and then we have the finishing window for the finishers to work the concrete, and then we have final set. So we have this long time to finish and then a quick final set. When we add a retarder to the concrete, it takes longer to hit its initial set. You have a little shorter finishing window and then your final set. When you add a hydration stabilizer, you actually have the same amount of initial set, you get a longer finishing window, and then you get your final set. And I think the easiest way to explain the difference of the two is in a basic old school retarder. If you wanted to go from 60 minutes to 90 minutes, you would add the chemical retarder and it would hold the concrete to give you more time to finish the concrete. But when that retarder wore off, the concrete would kind of flash set and take off and harden. The way hydration stabilizers work is if you want to go from 60 to 90 minutes to be able to finish the concrete, you put the hydration stabilizer chemical in there, and then at 90 minutes, only a little bit of it wears off. And then at 100 minutes, a little more wears off. 110 minutes, a little more wears off. So it actually gives the finishers more time to finish the concrete. It's more finishing friendly. There's no kind of flash set of the concrete. So they're very finisher friendly. It's great new technology that the concrete industry is using. We talk about accelerators, right? We showed you how you could put a retarder in the concrete to slow the concrete down, but you can also put an accelerator in the concrete to speed it up. Maybe you want higher release strength to open up a concrete pavement sooner rather than later. So you can see the green line is a typical concrete mix with no accelerator in it, compared to the yellow line that has accelerator in it. You can see in the 7-hour range, you went from 1,000 PSI with no accelerator to a concrete that has accelerator, you're at 4,000 PSI. So instead of waiting days to open your concrete, you can open it in actual hours. So that's kind of the benefits of an accelerator. In cold weather or high early strength requirements, accelerators are used. Benefits of chemical admixtures, right? You can reduce the amount of water needed in concrete. You can increase workability without adding water. You can retard or accelerate the set time. You can reduce slump. You can modify the rate or capacity of bleeding. You can decrease shrinkage. You can reduce plastic or drying shrinkage. You could reduce corrosion. You could produce colored concrete, or you can produce cellular concrete. So there are a lot of benefits to using admixtures in your concrete. How does cold weather affect concrete? We kind of see here, if we had a 70-degree concrete, this concrete mix would approximately set in 6 hours. And every degree of concrete that, every degree in concrete temperature that the concrete decreases. So when we go to 60, we go to 8 hours. When you have 50 degrees, we go to 11 hours. 20 degrees, we're not going to get any set. So it just goes to show you why keeping concrete temperatures are important, and that in cold weather, practices need to be taken to keep the concrete temperatures up, and then also protect the concrete when the concrete is placed, so that it keeps that temperature and it sets and it gains strength. For every 20 degrees change in concrete temperature, your set time doubles. That's the basic rule of thumb. How does it affect concrete strength? You can see if you keep your concrete at 73 degrees, this concrete mix reached about 70, let's just say 7,000 PSI. If we took that same mix and we kept it at 25 degrees, we didn't protect it, we didn't have warm weather concrete, we only ended up at 3,000 PSI. So it just shows you that you lost 4,000 PSI in your concrete by just not keeping the concrete the right temperature. How does hot weather affect set times? We talked about cold weather. Let's look at hot weather. If we had our typical 70-degree concrete, that concrete mix would set in 6 hours. But when we get to 80 degree, we go to 4 hours, 90 is 3, and 100 degrees is 2. The big issue that you see with that is that how how are concrete finishers going to finish the concrete if it's only setting in 2 hours? They might throw water on it. It could cause all types of issues. So this is just a good chart to show you how just concrete temperatures changing can affect the set time of the concrete. Talk a little bit about fibers, right? There's monofilament. The first type of fiber is what we call monofilament stealth or finishing fiber. It's made from polypropylene. The dosage rate in concrete is typically 0.5 to 1 pound per cubic yard. And it's basically for plastic shrinkage cracks, right? So if you have, if you're the water, right, the concrete's gonna bleed. And that means there's gonna be a little bit of water ponding on the surface of the concrete. And then that concrete's gonna, that bleed water is gonna evaporate. Sometimes if that happens too quickly, we get all these little plastic shrinkage cracks on the surface of the concrete and it just looks bad. But if you put in 0.5 to 1 pound per cubic yard of this type of fiber, it lays across that surface and it doesn't allow that cracking to happen, that plastic shrinkage cracking. And it's very inexpensive. The next type of fiber is what we call fibrillated fiber. There's 3/4 to 3 pounds per cubic yard is the standard range for this fiber. 1 to 1.5 is typically what we see people use. It will replace welded wire fabric in driveways or patios, but it has no post-crack control. And what that means is right, everybody in this industry defaults to welded wire mesh. It really doesn't do much for you. Welded wire mesh does not stop cracks from happening. The only thing welded wire fabric does is once a crack happens, it holds it together. But the problem with welded wire fabric is if a crack starts at the top of the pavement and starts to travel down to the bottom, it's going to keep opening up till it actually hits the welded wire fabric at the bottom of the pavement. So that crack's going to open up and it's going to get wide. But with fibers, they have the same responsibility. They don't stop cracks from happening, but they hold them together once they happen. With fibers, the fibers are from the top to the bottom of the pavement. So when a crack happens at the top of the pavement, it immediately hits a fiber and it can't open up anymore. So it's not as sightly, don't open up as much, and it's a much better concrete pavement with fibers compared to a welded wire mesh. Then we get into what we call macro fibers. We typically see 3 to 12 pounds per cubic yard is the range that you can specify for these fibers. 3.5 to 4 is typically what we see in our concrete pavements. It replaces wire mesh, steel fibers, light rebar, and other secondary reinforcing slab on grade composite steel for floor decks. It provides post-crack control performance. This is starting to where you get an engineer involved. So most fiber companies have an engineer on staff. They can help you look at your pavement, see what you're trying to do, and they can talk to you about the different dosage rates of fibers and what you can do with your concrete pavements. And last but not least is steel fibers, right? They increase structural strength, fatigue and impact resistance. They give some ductility to the concrete. They stop micro cracks and they relieve internal strain. We typically see 40 to 70 pounds per cubic yard. So we see a lot of interior floors either use macro fibers or steel fibers to take those joints from like 50 feet to 150 feet. So that's kind of another trend we see in our industry. So fibers are good. If you're not up to date or not specifying them, you can always call IRMCA and we can help you with that. Concrete testing, right? So we talked about our concrete, basic concrete mixes, all the materials that are in there. So we created our concrete mix. How do we even test it to know that the concrete mix is good? So here's the different ASTM standard tests that you use to test concrete. Sampling is important, right? ASTM C172 is what's used to tell you how to sample fresh concrete. You need greater than 1 cubic foot of concrete to perform your tests, less than 15 minutes between the first and last portion of your sample. And the sample should not be taken from the first or last portion of the concrete truck, right? You want your concrete sample to test that truck from the middle of the truck, not the very first or last part of that concrete mix. So this kind of shows you how you should sample concrete to then perform your test. The next test is the test for slump. As you see, here's a whole bunch of different pictures of slump tests being performed. You fill your slump cone in 3 lifts. You rod 25 times each. You lift the cone in plus or minus 5 plus or minus 2 seconds, and you measure to the original center. This is going to tell you a slump number. So like a 2-inch slump, a 3-inch slump, a 4-inch slump, a 5-inch slump. And that basically tells you how workable your concrete mix is going to be. So when you design a concrete mix, you're going to design a water cement ratio, and you're going to want to have a intended slump that concrete mix should be poured at. And this is kind of the test that shows you what slump your concrete is. Temperature, there's a specification for temperature. Minimum 3 inches into the concrete, you got to stick your thermometer. You got to close the void around it, right? When you stick it in the concrete, there's going to be a little void around the part that goes in. You got to push it back around the thermometer. You can hold it in there for a minimum of 2 minutes, but a maximum of 5. And most importantly, you read the temperature while the thermometer is in the concrete. You don't pull it out and look at it because the wind or the ambient air is going to change the temperature. So you want to take your reading while the thermometer is in the concrete. Right, we do have a ASTM standard for unit weight, yield, and air content. So we basically take a bucket and put concrete in there. There's a whole standard for that, and it basically helps us understand, did our concrete yield right? So, right, a concrete is designed to cover cover a certain amount of area, right? Sometimes someone might call and say, oh, I got a shortage. I ordered 5 yards of concrete, and I poured it out, and I'm still 2 yards of concrete short. What happened? Did you not give me enough concrete? This yield test right here is what tells you, are you actually getting the cubic yard of concrete that you paid for? Did the concrete plant underbatch something, underweigh something, make an honest mistake, you know, things like that? Did a bunch of concrete get stuck in the truck and it didn't come out? You know, so this test is what's used on site to see, is that truck giving me the right amount of concrete that should be in that concrete truck? Right, we have a standard test to determine the air content, right? We talked about concrete that is exposed to freezing and thawing needs to have a certain amount of air, right? Typically 5 to 8%. And here's the equipment used to determine if your concrete has that 5 to 8%, right? You fill the pot in 3 layers, you rod it 25 times, and you tap each layer 10 to 15 times. And then you take your, you'll be able to put the lid, strike it off, put the lid on it, put some water through the petcocks, close the petcocks, pump it up, and get your air reading. Right, we also make cylinders in the field to determine, does the concrete meet the strength that we required that concrete, that we specified for that concrete? So we use 4x8 cylinders. You fill them in 2 layers, rod each layer 25 times, tap each layer 10 to 15 times. For a 6x12, you fill it in 3 layers, rod 25 times for each layer, and you tap each layer 10 to 15 times. So this is the method that's used to cast cylinders on a project or in a yard, and then you go ahead and you break them at a certain age to determine, did the concrete meet the strength that it was required to meet? Part of that standard is how you actually store the cylinders, right? So we cast them. Let's just talk about a concrete project job site. So we casted our cylinders. They can only sit on the project for up to 48 hours. And during that 48 hours, they must be kept at 60 to 80 degrees. That rarely happens, but that is one of the leading causes on why we get failed cylinder breaks from a job site. So it is very important, if you're an engineer and you're specifying concrete, these rules need to be followed here. Right, and after we've picked up the cylinders from the job site, we take them to the concrete plant or lab plant, and they have to be stored at 73 plus or minus 3.5 degrees in a moist cure room until they are ready to be broken. So it's very important that we know these standards and we follow these standards when we're trying to make cylinders and then break them for test data. I was checking my time. Here we're going to look at a different couple scenarios and see if they're doing it right or wrong. So here we see a bunch of cylinders in the back of a truck, and we're wondering, are they've picked them up at a job and now they're going to take them to their lab? Are they doing it right? The answer is no. Look at this gentleman. He saw this and he wants to throw up. He wants to throw up in his mouth. You cannot just put cylinders in the back of a truck and then drive them around. As you hit bumps or you stop too fast, those cylinders will slide back and forth, and they can actually cause micro cracks. So then when you go to break them, you'll get false low readings, and that causes all kind of problems on a job site. So again, if you're going to put them in the back of the truck, they need to be put in storage containers that will not allow them to move around. Here we got a curing box that actually has a temperature reading. It's got a thermometer, and we can keep it between 60 to 80 degrees. Is this right? Yes, that's the right way to actually store cylinders on a project. They need to be temperature controlled to be kept between 60 and 80 degrees. Here we see some cylinders on a job site. They've got bags on them, but they're stuck in a bunch of snow. Definitely not right. That is, you should never see that on a job site. And if you see that on a job site, those cylinders should be thrown out or disregarded. Here we see a cooler. We've got a bunch of cylinders in there. There's some water in the cooler. Is this a good way to store cylinders on site? Absolutely. If there's one change in the concrete industry, if you're an engineer, part of your pre-construction meetings, there should be those type of curing boxes on your projects to store cylinders. Here we see a good attempt, right? We've got cylinders, we've got plastic bags over them. They've got some cardboard over them. They've took some extra time and care. Is this right? Kind of yes and no, right? They've actually covered the cylinders with some plastic. They got some cardboard to keep the sun out, but unless it's going to be 60 to 80 degrees for the 2 days that they're out on site, they need to put them in a curing box to make sure that they're the right temperature. Here we see some cylinders sitting out in the sun. Is this the right way to store cylinders? Absolutely not. This guy pulled his hair out looking at it. They had caps with their cylinders and they didn't even bother to put them on there. It is very important that you cover your cylinders to keep the moisture in them. What causes low cylinder breaks on jobs? Cylinders not made properly. Cylinders are not stored properly, right? We talked about first 48 hours, 60 to 80 degrees. Cylinders are moved around before we're set. Sometimes we see people cast cylinders. They come back 4 hours later and then move them. But it's right in that kind of phase where the concrete's starting to set in that cylinder and they actually cause cracks by moving them. And then the cylinders break bad. Cylinders left out in the sun. I don't think a lot of people are aware, if you leave cylinders out on a 90-degree day in the sun, you actually cook the cylinders and then they stop gaining strength. They'll never gain any more strength and you're going to get false bad readings on those concrete cylinders. Cylinders are not stored on ground level. If you make them and you don't store them on ground level, they become very slanted. And when you put them in the cylinder machine, they're going to get a false bad break because it's not perfectly level on the face of the cylinder. Cylinders in the field too long, they can only stay 48 hours, right? We see sometimes people make cylinders on Friday and don't pick them up till Tuesday. That's way too long. Sometimes it's a concrete producer's fault, right? Maybe you shipped the wrong mix. Adding addition of water, right? We talked about water cement ratio. The more water you add, you break that water cement ratio, you're going to cause low breaks. High air, right? The concrete's designed to be between 5 and 8%. If you have 10, 11% air in your concrete, your strength's going to go way down. So you'd get bad cylinder breaks. Right? You want to review the batch sheet, see if the problem was something that happened at the plant. These are all different reasons why concrete cylinders can break low. We're running out of time, so I'm going to speed it up a little bit. I apologize. We're covering a lot of stuff here. All good things to know. So curing, right? Curing is the maintenance of a satisfactory moisture and, content and temperature in concrete for a sufficient period of time immediately following the placing so that the desired properties are met. Again, I think the biggest mistake people make is they don't understand that curing has two requirements. It's actually you have to keep moisture in the concrete and you have to have the right temperature. We saw a couple different slides that showed how hot weather and cold weather negatively can affect concrete. So during the curing period, which is the first couple of days, mostly 7 days, you got to make sure that you're keeping moisture and temperature in the concrete. Why is curing important? It minimizes or eliminates cracking. It improves the strength greatly. It creates a water tightness in the concrete, and it creates increases abrasion resistance. It improves durability, right? It improves resistance to freezing and thawing, and it improves resistance to the icing salts, right? exterior slabs are completely, how can I say this? It is very crucial to make sure that you have some curing in place for any concrete that is going to be exposed to freezing and thawing. It's really crucial that if you're an engineer and you're going with your contractor and talking about how he's going to handle the concrete, a curing method should be discussed and looked at. Effects on strength, right? If you see the brown line, a standard no cure could give you a 4,000 PSI mix. But if you take that same mix and you cure it with a moist cure for 365 days, you went from a 4,000 to an 8,000 PSI mix. So it just shows you that having the proper curing methods can really improve the strength and durability of your concrete mixes. And there are all different methods out there for curing. You can see some of the different type of curing applications here. And in the bottom corner, you actually see the winter blankets down on the concrete pavement to make sure we got that temperature part of the curing covered. Here's an example of curing that's poor. They sprayed the white pigment on it, but you can see all the gray through it. It's really a bad job of curing. Here we see a much better job. They're putting it on a little thicker, really covering that concrete. And this is actually how your concrete should look when you cure it. A white pigment is good to specify because you can actually see the rate at which they're applying it. And that's the goal, is to lock that moisture in there. So you really need good coverage. Wrapping it up, a couple new trends in the concrete industry. Our industry is moving to e-ticketing. So if you're an engineer, it might be good to put some kind of specification in to allow e-ticketing. IDOT, Tollway are working on that now. We've also had some successful projects with e-ticketing. In summer, right, we got to cool our concrete. We're seeing a movement to liquid nitrogen. So concrete producers are actually installing liquid nitrogen systems on their plant to cool the materials as they come down the belts. We're also seeing a movement to low GWP or reduced CO2 concrete specifications for parking lots and interior floors. This is a big trend in our industry. IRMCA is working on a specification for the engineering community if you're interested in specifying these types of concrete for your concrete parking lots or interior floors. As we discussed earlier, there is a real want and a movement towards Portland limestone cement instead of type 1, type 2. We covered that a little bit earlier, but that's a new trend we're kind of seeing in at least the United States. Concrete parking lots. We see a lot of industrial buildings going to concrete parking lots in our market. So it's a very favorable trend just based on maintenance costs and durability. We're just seeing a big movement for especially industrial parking lots to be concrete. IDOT, our industry just worked with IDOT. They created a special provision for a cement slurry for FDR, full depth reclamation. Currently, you might see lime or dry powder cement. Now we can deliver a cement slurry in a ready mix truck, which is a great new concept. So we look forward to talking to the engineering community about specifying cement slurry for those types of projects. Here's an example of some of the benefits of using liquid nitrogen. Again, it's one of those new technologies we're seeing emerge. It's just safer, it's convenient, it's an ease of use, it goes right on the belt, and we can cool concrete in excess of 40-degree deltas, which is big deal when you have hot weather or mass concrete. And it kind of just shows you the liquid nitrogen replaces chillers, cooling tubes, ice machines, ice welt belts, injected methods. So a great new technology that we're seeing. One last thing, there's what we call concrete in practice CIPs. They're produced by the National Ready Mix Concrete Association, and they have just these great documents on all these different topics in the concrete industry. If you're an engineer and you see any of these topics that you're interested in, shoot me an email and I'll send you over the CIP. It's a great way to just get yourself a little more knowledge on all these different concepts in the concrete industry. In closing, our next webinar is in June 16th at 12 p.m. It's entitled Full Depth Reclamation with Cement Slurry Using a Ready Mix Concrete Truck. Speakers will be Don Clem from Colorado. He's with the National Ready Mix Concrete Association. We have Jonathan Pease, who is the contractor with Rock Solid Stabilization and Reclamation. He's done a lot of it. It's going to be a great speaker, a great presentation. Registration will open on Monday, June 7th. And we did have one question. I want to go back and answer this question.
Yeah, Theron, Michael is asking what is happening chemically that the slag mix strengthens over time?
I guess I can't explain the chemistry. I can talk to some of our slag producers and get an email back to you. I don't know the chemical aspect of it. I just know that all the studies show that when you put slag or fly ash in a mix with, 5, 10, 15, 20% replacement, it'll slow down the earlier strengths, but it actually will increase the overall 28-day strengths and beyond. So I apologize. I don't know the chemical answer for it. Michael, I will talk to the slag guys and I will get you a written response on why that happens. It says,
Thank you,
how is
Darren.
the excellent, oh, go ahead.
Yeah, we have one more question from John. How was the excellent curing example achieved?
That was actually like an IDOT, or I would say like a DOT pavement. And there was actually a machine they used that spread the curing compound over. It was like it sprayed it through all these different bars across the pavement and down the sides. And they just drove the machine slow. John, the biggest part of that is, even if you're doing it with hand sprayers on, let's just say, parking lots or something simpler, the rule of thumb is just cover it so you can't see the gray behind through the white pigment. That's really the goal you're trying to achieve. A lot of projects, when we go out there, we see they spray the curing compound on, and it really doesn't do anything. It's not causing a barrier. It's not keeping the moisture in. It was just kind of a waste of money. So if you actually have contractors that are going to cure, the goal is to say, if you're going to use a pigment, spray it on so that we can't see it.
Great presentation, Theron. We've had, looks like almost everyone stayed with us this afternoon. Our theme is to design with concrete. And if you want to know more details and go into greater depth with everything that Theron's presented today, just give him a call. You'll find his number there at the bottom of the screen. And it's real easy to go to irmca.org at our website to review these webinars and to get in contact with Theron. So great job, Theron. Thank you.
Thanks, Jim. And thanks, everybody, for tuning in. Appreciate it. And as Jim mentioned, anything that you heard here today, if you'd like a little more information or talk a little more, we'd be glad to help you, and hopefully see everybody on June 16th. Great new technology. IDOT just specified it, and we're excited to get going with the engineering community.
That'd be a great one for the county engineers. So anybody that can call their county engineer friends, this is a great application on the reclamation of roads. So also legislatively, we're seeing a lot more funding coming out to these agencies, local roads, highways, state roads, and county roads. So let us help you out and put those funds to good use with concrete or reclaiming even on your county roads.
Thank you, everyone.